Imagine looking up into the deep, dark velvet of the night sky, a canopy glittering with countless stars. Now, picture an ancient human ancestor, tens of thousands of years in our past, carving a notch into a piece of bone for every full moon that passes. Then, transport yourself to a brightly lit room today, where a physicist stands before a sprawling whiteboard covered in a beautiful, complex web of equations. From the star counter to the bone carver to the modern scientist, a single, unbroken thread connects them: numbers. But this thread leads us to one of the most profound questions we can ask. Are numbers something we invented, or are they something we discovered? Are they human tools, or are they fundamental truths of the cosmos, waiting for us to find them? This isn't just an abstract puzzle for philosophers locked away in ivory towers. It touches the very core of our relationship with the universe. If we made numbers up, then our most powerful tool for understanding reality, mathematics, is a human construct, a language we designed. It would be an astonishing coincidence that this made-up language so perfectly describes everything from the orbit of a planet to the swirl of a galaxy. But if numbers were already out there, part of the cosmic architecture, then our journey of discovery is even more magnificent. Our first stop on this journey is the most practical, down-to-earth perspective, the idea that numbers are a human invention. Think of them not as mystical entities, but as tools forged to solve real-world problems. Our ancestors didn't sit around contemplating the abstract essence of three. They needed to know if 3 wolves were circling the camp. They needed to know if they had enough food for 3 days. The earliest evidence, the 35,000-year-old Lobombo bone, shows simple tally marks. These weren't sophisticated mathematics. They were a technology, a way to record information, a memory aid more reliable than memory. It was a tool for survival. As societies grew more complex, so did numerical toolkits. Ancient Sumerians in Mesopotamia needed to manage a sprawling agricultural empire, divvy up grain, build massive ziggurats, track planting and harvesting time. Their solution? A base 60 counting system. We still see it in 60-second minutes, 60-minute hours, 360 degrees of a circle. Different cultures invented different systems for convenience. Some used base 10, likely from 10 fingers. Others in Mesoamerica used base 20, fingers and toes. This diversity is a clue. Why so many systems if numbers were universal? Mathematics is like a language. It has a grammar, rules of arithmetic and algebra. It has a vocabulary. Now, let's take a leap from the practical world into a realm of pure, unchanging perfection. This second viewpoint, championed by Plato, presents a radically different idea. Numbers are discovered. Numbers in mathematical forms exist in a separate, abstract reality, a world more real than our senses. We can draw a circle in the sand, but it will always be imperfect. The line will be wobbly, the curve not quite uniform. But the idea of a circle, defined by x squared plus y squared equals r squared, is perfect and unchanging. We don't invent that perfection. Our minds glimpse it. Consider the prime numbers. Those numbers like 2, 3, 5, 7, 11 that can only be divided by themselves and 1. No human committee decided which numbers would be prime. They follow mysterious, intricate rules, stretching out to infinity. Mathematicians feel like explorers mapping a new continent. They uncover unexpected patterns, like the Riemann hypothesis, a deep, unproven conjecture about prime distribution that holds for trillions of examples. These patterns were there long before we noticed them. They are features of the numerical landscape, not markings we made. This feeling of discovery is common among mathematicians and physicists. When they find an elegant equation or deep theorem, they speak of its beauty and truth. Eugene Wigner wrote about the unreasonable effectiveness of mathematics. Why should abstract mental games be the perfect language for the real world? Why does an equation on a blackboard predict a new particle? Section 4. The biological interface. What if the answer isn't a stark choice between invention and discovery? What if it lies somewhere in the middle, in the amazing 3-pound universe we each carry inside our skulls? This perspective suggests our ability with numbers is a product of evolution. Our brains didn't evolve to ponder prime numbers. They evolved to help us survive. Distinguish 1 predator from 3 predators. Remember 5 fruit trees versus 2. Those differences were powerful survival advantages. Our brains became pattern-detecting machines. Think of the brain as an interface, a kind of biological software interpreting raw sensory data, like a computer OS presenting information with icons and windows. Our brain processes the flood of sensory input and organizes it into useful concepts, including how many. This innate number sense isn't formal mathematics, but it's the seed from which it grows. Our minds evolved to find stable, predictable patterns because that helps organisms survive. The laws of physics are stable. Section 6. The unreasonable effectiveness. This brings us back to that central mystery, the one that so captivated Eugene Wigner. Why is math so good at explaining the universe? If it's just a human invention, a game we made up, why does it have such spooky predictive power? In 1915, Albert Einstein wrote down his equations for general relativity. He used a form of geometry developed decades earlier as a purely abstract exercise. His theory predicted that gravity could bend light. A few years later, during a solar eclipse, astronomers pointed their telescopes to the sky and saw it happen. The starlight bent, just as the math said it would. It was a moment of profound revelation, a human idea perfectly mirroring a cosmic truth. Paul Dirac formulated an equation to describe the electron. The math suggested the existence of a mirror image particle, one with a positive charge. This positron, antimatter, was a purely mathematical ghost at first. Section 7. The universe waking up. So, where does our cosmic journey leave us? Have we found a definitive answer to whether numbers are made or found? Perhaps the real answer is that the question itself presents a false choice. It asks us to separate 2 things: the human mind, the universe, that are inextricably linked. We are not aliens who landed in this cosmos from the outside. We grew out of this universe. We are made of star stuff. Our minds are a product of the same physical laws that govern the galaxies. The separation is an illusion. Let's try to weave the threads together. The universe has deep, underlying, and consistent patterns. The laws of physics, the logic of quantity. These patterns are real and exist independently of us. They are the discovered part. Then there is us. We are living beings who evolved within this patterned universe. Our survival depended on our ability to recognize those patterns. Our brains developed an innate number sense as an interface with that reality. This is the biological part. Finally, using language and culture, we built upon that innate sense, creating formal, symbolic systems, mathematics. Math isn't magic, it's everywhere.